welcome. Thanks for joining here. Today's talk is to SSR or not to SSR, choosing the right rendering strategy for your web app. My name is Bartosz, and here with me is Martina.
Hello, yes, I'm Martina, and we're here to talk about and to look at the various rendering strategies together. So we'll talk about the client-side rendering, server-side rendering, static-side generation, and also distributed persistent rendering and incremental static regeneration. So, and we'll talk about when to use them, and most importantly, when not to use them.
And don't worry, we're not going to do any live coding, so it's going to be more about concept, exactly the stuff, framework agnostic. We're going to just focus on going through all of them and to show you pros and cons and stuff like that. And the real world examples, of course. So that's, if you didn't know, that's us. I did not that slide. Who did that? Next one. So why do we even ask this topic? Why SSR as why not or not? Well, because the SSR lately make a big comeback. It was long time ago a de facto standard, then kind of disappeared. And now if you look around, it is a part of all the existing framework, or a lot of solutions, monolithic, non-monolithic, the CMSs and so on and so forth. It kind of became de facto standard. For us front-end developers, it has been popularized by the frameworks like Next, Nux, and all those fancy stuff that we work with on a daily basis. They went this route, and because they become de facto at default configuration for those things, we kind of just started choosing them without even realizing.
But just because it's popular, it doesn't mean it's always a good fit. So in the early web, we've seen the server-side rendering. We always got the full HTML returned to us. Then the SPA era came, so single-page applications. With that came the client-side rendering, and all the logic moved to the browser. Now the frameworks are bringing back the SSR and SSG to enhance and to make the performance better, and also SEO. But SSR is not always the best option or the best fit. It adds complexity and cost. And we're here to navigate these options.
So that's the agenda for the next 20 or so minutes. We're going to do the overview of all those rendering strategies, this nice fancy acronyms as you see here: CSR, SSR, SSG, ISR, TPR. Don't worry, we're going to kind of make them known to you. We're going to look at how each works. We're going to talk about the pros and cons and trade-offs of every one of those frameworks.
And we'll also look at some real-world use cases and how we can combine these strategies together. And we will wrap up with key takeaways. So let's start.
All right. So let's first look at the layout of all 5 of different strategies. So we have, on one side, we have CSR, the client-side rendering, where everything we see, everything our user sees is rendered in the browser by the JavaScript. On the completely opposite side of this spectrum, we have SSG, the static side generation, where everything is rendered ahead of time. It's a nice HTML. It's sent directly to our users, nice and fine. And in the middle, in between those two, we have something what we call the server-side rendering, where each HTML is rendered on the server on every request from our end users.
Then we have ISR, which is incremental static regeneration. That means that we pre-render all the pages at the build, but then we update just the pages that are needed in a certain time frame. And DPR, distributed persistent rendering, that means that we have on-demand page generation just when it is needed. And then it is cached for other visits.
So look at that and think of it as a toolbox of the things that we can use. So not one thing fits all the problems, but that's what we're going to find out in the next few minutes. So let's go. The first stop on our lovely agenda is the client-side rendering. So the way it works, a lot of you might already know, but we're just going to do a quick refreshing. It's that the server sends just a small HTML, sort of a container, a simple index HTML, and a huge JavaScript bundle, which then browser takes in. JavaScript does all the magic, renders everything that our end user sees, and everyone's happy. It's very common with the stuff like React, Angular, Vue, all those CSR things that you probably worked on before. So very simple index HTML, very little things to see at the beginning, and everything is nicely rendered on the end user browser.
When we look at the illustration, we see how it goes. So at the build time, we see all the like JS components logic are bundled, and then the browser gets an empty HTML shell and then renders the UI components directly on the browser.
So let's look now at the weaknesses and strengths of the CSR. So there's a lot of reading. Don't worry, we're sharing the presentation I've heard, so no need to take pictures. So the pros. The pros would be a very nice rich app like an interactive. I'm really bad with English, but nice snappy navigations, all the interactions that the users do in the browsers, they're very nice, very rich, very quick, because everything does happen on the browser itself of the user. It also comes with a super simple deployment, because at the end of the day we just have a one index HTML, usually one JavaScript. We just drop it into any web server and we serve it for any request that comes our way.
But of course, there are some downsides as well. The first thing is the slower first load. The user often sees first the blank page or a loader bar, and it takes some time till the browser renders everything. And we can mitigate it with some things, for example, creating some skeleton components, but still it takes some time. Also, the performance hit is visible on some older devices or slower networks, especially when the JS bundle is big. Then, of course, the SEO challenges because content is not in the initial HTML. Traditional crawlers are not always able to execute the JavaScript. We've seen some improvement in this area. For example, Google is able to execute the JavaScript already, but still some traditional can have some issues with that, and also using the social media previews can be a problem.
And as for developer experience, for us, it's a very simple deployment, as I mentioned. Static hosting, few files, drop in, done. Super nice and simple. We don't have to care about anything server side to manage anything states, any crazy stuff, no debugging there. We don't really care about that. But debugging on the front end can be sometimes tricky, because at the end of the day, to see the final performance, it happens a little bit in the wild. So it can get tricky when we try to debug exactly what's happening on our end users end. The SEO workarounds, what Martina mentioned, that can be a little bit tricky if we want to work with it well. We can and have to do sometimes some things and tricks here and there to make it work. But as Martina mentioned, for example, Google is already pretty good at that. If you guys are joining our workshop tomorrow, as a little advertisement, we actually will show you what Google sees when you deploy a client-side rendering, and if it's actually matching what you think it does match.
Now, when to use the client-side rendering? It is best for apps that need a lot of interactivity and personalization. It's ideal for dashboards, some internal tools, and spa-like experiences. It's also best for apps that are behind login and where SEO is not really relevant.
All right, so that was CSR. Next on our list is the server-side rendering. So in that scenario, what happens is the request comes into the server, then the server grabs all the data it needs, it makes it a wonderful HTML and sends it straight back to our end user. So what the user gets is a nice HTML page. It is really great for dynamic and personalized content, because then every user needs something special, something extra. So obviously we want for every request to be treated a little bit different, and that's what it is for.
And again, we can see that in the illustration, at the build time, the code is bundled, but it's not generated. And then when the browser, for example, requests the page one, the server generates the page, and the HTML is returned to the browser as the ready-to-serve HTML.
A good example of the server-side rendering would be Next.js. You probably all heard of it. So for example, if you use it with this fancy get server-side props, I never remember. What happens, we tell the framework to grab the stuff on the server, prepare everything, make a nice HTML, send it to the user. Easy example, you probably all seen it at some point within your developer work. It is nice for the first paint. I think that's the name for the thing, the first paint, because the users immediately see some HTML. The user for the slower connection and so on immediately see something. They don't have to wait for all the JavaScript to build HTML. And it is the crawler friendly because there's already something to crawl. They don't have to wait for the JavaScript to build any front end.
Yes, because the browser already gets fully rendered HTML. Now let's look at some cons and pros.
So, the pros. Hey, the context is visible immediately. So our end users get entire page at the glance. They load the page, everything's there. This is very nice. It makes all those crawlers happy as well as those Google metrics very happy because hey, it's easy to look at the stuff. They're already there. No issues there. So great for the crawlers. Also, as mentioned before, great for the pages that needs a frequent updates. So we don't have to rebuild it or anything like that because every request is treated separately at the time when the request comes in. Then our lovely server fetches all the related real-time data and it is returned as the current state persists. What do I have here? Yes, it also works well for logged in dashboards and e-commerce.
But we can still see some slower response when we compare it to the SSG because server has to render it on every request. And with that comes also that it can be harder to scale because when a traffic spike happens and many users want to request the same page, it has to render it all the time. So with that, we have to plan for a good backend infrastructure. So the SSR brings some complexity because we have to handle the runtime environment, caching, and also the error handling.
So as for developers, the more complexity, as Marcina mentioned, because it's also complexity. What do we want to do on client versus what do we want on the server side? Because nowadays we can kind of cherry pick what needs to happen in which place. So that adds an extra complexity when we work with the code. It means also we need a runtime. We need to run our server somewhere. So that is also can be tricky. We do know a lot of platforms right now kind of take away all the complexity, but it is there. It's still there. It's hidden, but it is still there. So that means we still have to care about it. That also means we have to care a little bit more about the caching because each of the frameworks and platform can have a little bit different strategies. Does not mean that we have to now look at what we're doing because that means also we have to look twice at what those frameworks doing as well as what we're doing with a good old headers. That means also a server cost can be higher. So us as developers, we do have to care about it a little bit. So we need to make sure that we're not gonna boom our budget, and the error handling can become a very, very tricky because right now we're not only looking at errors that happen on the client side, we need to look at both worlds and error debugging on the servers when we're running server-side rendering can be a little bit tricky. Looking at the different functions, which eats all up the memory and so on and so forth, can get a little bit complex.
Now again, when to use it? The server-side rendering is ideal for the content and for the pages that must be fresh, but also SEO friendly. It's ideal for e-commerce pages, some landing pages, news, etc. But we have to make sure that we think about the case that it might not be worthy for the apps that are behind the login or that don't really need the SEO.
You're right. The next on our journey is static site generation. So what happens here, we pre-render all the pages, usually at the build time. And then what we do is we just drop them in our web servers, and what the user get is just a full ready HTML. So let's say if we have a marketing campaign pages worth of 50 pages, what's going to happen at the build time? We're going to build ready to load 50 different HTMLs. We drop them on the server, on our web server, CDN, whatnot, and that's how we send them to our end users.
We see it in the illustration again. At the build time, the pages, the HTML is directly generated, then they reside on the server. And when the browser needs a page, we just get the HTML directly right away.
So this is ideal for things like blogs, documentations, landing pages. For example, Magnolia Documentations is done with this lovely approach, static site generation. So we build that whole documentations ahead of time. We dropped it on the server. That's why you have this blazing fast experience while working with Magnolia Docs. I hope. Let's look at the pros and cons on static site generation. So the pros, hey, it's super fast. Most cases, the stuff is going to land on CDN, so our end users get the responses immediately. You see an unparalleled load times. It's absolutely perfect. Super great for SEO because everything's there. All the crawlers love it, obviously, and all those Google metric pages thingies, they love it too, because this cannot be really matched with any other strategy.
Now, for the cons, of course, the stale content, right? When we build our page, for example, yesterday, and something changes, we don't see the changes right away. We have to rebuild the page and we have to redeploy. So it's not really ideal for real-time data and as well for the personalization. If we need per user content, we cannot really build thousands versions of one page, so it's not really good for the heavy personalization.
The developer experience. So we have to look at the few cons here as well. We can have a long build times. If our page is huge, it can get very long. And I do remember in one of the Magnolia clients, they had this approach and the build took around 30 minutes. So it can get tricky if, let's say, your marketing needs to fix a simple typo and we need to wait 30 minutes until stuff are deployed and actually fixed. So the updates can get very, very slow with this approach, provided you have a huge site, which most of you probably do.
Which can be nice, is relatively simple deploys for developers because we just deploy the static files. And the app is then stable and secure because we don't have any code running on the server or in the browser. But adding some interactivity can be tricky because we then need to work around the static site generated pages. And of course, the content updates require some rebuild, so we might have to plan for some good trigger pipelines.
So where does it work best? Well, with the places where we rarely change the content, like I mentioned before, blogs, documentations.
Common pattern is to mix SSG for static pages and use SSR or CSR for some dynamic parts. Now let's discuss some hybrid approaches.
So obviously, because of the pros and cons, and mostly the cons that all the three previous ones brought to us developers came up with the three new approaches to solve those issues, solve the things like the scaling of the page or the freshness of the content. So we came up with something called ISR, incremental static regeneration. What it does, it just regenerates builds at a certain time. So we do a little bit SSG and then we tell it, hey, regenerate every page every 60 seconds and so forth. The other one that we came up with was DPR, distributed persistent rendering. So this one takes it even a step further. We don't build anything ahead of time. We just tell it, hey, build only the pages that actually were asked for, and then do the refresh just like ISR.
Yes, we can think about ISR as auto-refreshing static pages. So we get the pages that are built and we can update them after deployment if it is needed within a set time window. And DPR, we can think about it as lazy generation. So first builds the page. It can be slower for the first visitor, but then it's cached and it is fast for others. And if we don't need, for example, page one, it will never get built.
So this is all cool, but it does bring a lot of hidden complexity. The new frameworks, the new platforms, they kind of take it away from us. But again, it's still there. It still can cause a lot of headaches. And those two can actually, in very many cases, can be replaced by a simple cache control header, which looks like stale while revalidates. So we set up what's the maximum age. Then while the user wants to access our site and it's already out of the max age, it will serve the stale version and in the background refresh it. So kind of what those two trying to do, but just with a simple browser header, which right now is really supported by most of the CDNs. So, the requirements and constraint for all those strategy selections, how do we know which one should we go?
The first question that we can ask ourselves is the SEO requirement. Do we need the search indexing? Is the social media preview important for us? Then we might want to go with SSR, SSG, or ISR. If we are building the internal tool or it is a tool behind the login, we don't need the SEO, CSR is fine.
We also have to ask how fresh must our content be. If it doesn't need to be too fresh, SSG a good idea. If we need to real-time updates, well, then maybe SSR is the way to go. If we want a best of both worlds, we look at the hybrid approaches.
Then, do we need user-specific content? If yes, we want to use CSR, or we might want to consider SSR with the CSR. But if it is only the public personalization, for example, cookies or localization, we can use SSR.
Scale. If we have million of pages, ISR, TPR, that might be the way to go. If we have something small, something little, hey, SSG is just perfect for you.
Then what is more important for us? It is the fast first load or interactivity. If it is the fast first load, we want to use SSR or SSG. If it is interactivity, then CSR is probably a way to go.
And the last not least, team and infrastructure. Look around what your developers feel comfortable with, what they know best. Don't force on them stuff that they're not feeling comfortable. They're going to deliver a great project with the skills they have, and we have a lot of stuff to choose from. So then strategy selection and some examples here.
Yeah. For example, small marketing site, there is important for us that it is simple, it's fast, SEO friendly. So we might want to use the SSG.
Content-rich blogs, docs, as mentioned before. Hey, SSG, that's the way to go.
Large e-commerce site, we might want to use mix because it might be a bigger page. So SSR, SSG for the main page to use the SEO, ISR for frequently updated product pages. If we are dealing with a large catalog of products, we might want to use the DPR, so not everything is always built, and CSR for some interactivity like cart or checkout.
And if we work, for example, with some social media, let's mix it. The things for public profiles can be SSR to update and CSR for internally navigated app after you log in.
An internal dashboard behind the login, no SEO needed, so CSR. If there is some heavy first load, maybe we can think about SSR.
And the most important thing is about campaigning strategies because, hey, there's no need to choose one approach. The best project actually mix and match different approaches together. So modern frameworks actually allow you to mix different approaches, not even on a per site pages, but per every page pages.
The example of such a hybrid setup can be a news site. We could have homepage that is with the SSR or ISR for fresh headlines. The article that would be SSG or ISR for some updates, comments. They are for the directly in the browser, so CSR to load after the page. So we see that we can also mix those strategies on one page.
An example could be in e-commerce, for example. A product page could be an SSG, and then what we're going to do is just a piece of the add to cart could be a CSR. So that thing that's not really important for SEO or crawlers, we can add it later after the user logs in. So the idea is that we want to optimize each part of the page. Think of really every site as an individual part of your project. Then more stuff. Is that the right stuff? Yes, we can also look at a little advanced stuff like an edge rendering. We hear a lot about it, that we can do the server-side rendering, but not necessarily on one localized server in a certain part of the world. But actually nowadays with the new platforms, we can split our server-side rendering at the edge of the whatever the world, so the person accessing our stuff get the server side experience, but it's super fast because it happens right next to their doors.
Then we have partial hydration or islands. The point of this is to hydrate only interactive parts. So we skip JavaScript for the static content. And it's not really a rendering strategy, it is more than optimization for the SSR or the SSG.
And the future is partial pre-rendering. So actually a new frameworks, they kind of choose for us what should be pre-rendered, what can be rendered after the load, and so on and so forth. So probably maybe in 2026 dev days, we're not going to even talk about it anymore because the framework will do all the magic choosing for the strategies for us.
And it's crucial for architects and developers to understand these strategies and to know how to combine those. So let's summarize the key takeaway from this talk.
So match the strategy to your case. Look at your project and make sure you understand the pros and cons of each of the strategies and what your project actually needs.
Keep it simple. Don't always default to SSR. It adds costs and complexity. So start simple and you can always scale up only if you need it with the SSR or ISR.
Weighing the performance versus complexity trade-off. Look at that very carefully.
And choose strategy per page. You don't have to think for the whole app. You can think page per page, feature by feature.
Well, optimize for performance and simplicity. We still have to maintain that code. Don't over-engineer it. There's no need to use all those fancy strategies just because they're out there.
And so after this talk, we hope that when someone asks to SSR or not to SSR, your answer will be, it depends. Let's talk about the use case.
Thank you very much.